The 1980s were supposed to be the future of bulldozers. More power, more comfort, more technology. What many operators actually got were unreliable hydraulics, fragile electronics, overheating engines, and repair bills that never seemed to end. These machines didn't just disappoint. They earned reputations so bad, crews refused to run them. Some nearly destroyed the trust in entire brands. They looked good on paper, they failed in the dirt. Today, we expose 10 of the most hated bulldozers from the 1980s, machines operators remember for all the wrong reasons. Number 1. Caterpillar D4H. The Caterpillar D4H entered the market in the late 1980s, during a period when Caterpillar was actively transitioning some of its smaller and mid-sized bulldozers toward hydrostatic drive systems. On paper, the D4H represented progress, smoother control, better maneuverability, and improved efficiency for fine grading and lighter earth-moving tasks. In practice, however, the machine quickly became one of the most criticized Caterpillar dozers of its era, particularly among experienced operators accustomed to traditional mechanical drivetrains. The core issue was not that the hydrostatic system was inherently flawed, but that it behaved very differently from what operators expected a bulldozer to feel like. Hydrostatic drive prioritizes control and responsiveness rather than raw drawbar pull. Many operators found that in sustained heavy pushing, such as dense clay, hard pan, or deep cut work, the D4H felt weaker than earlier mechanically driven machines of similar size. This perception alone was enough to generate strong resentment, especially among contractors who expected Caterpillar machines to excel in brute force tasks. Maintenance further fueled dissatisfaction. The hydrostatic system required cleaner oil, stricter filtration, and tighter service intervals than older machines. For operators working in dusty or remote environments, this was a significant disadvantage. Problems that might have been minor inconveniences on mechanical machines could become serious issues if contamination reached the hydrostatic components. Diagnosis also required more specialized knowledge, which many field mechanics did not yet possess at the time. Another factor was timing. Many D4Hs were sold to customers transitioning directly from decades-old mechanical dozers. Caterpillar's training and dealer communication were not always sufficient to explain the machine's strengths and limitations. As a result, machines were often misapplied to work they were never designed to dominate. Importantly, the D4H was not unreliable in absolute terms. In appropriate applications, finished grading, lighter construction, and jobs requiring frequent direction changes, it performed well. But reputation is shaped by expectation, and in the late 1980s, expectations for Caterpillar bulldozers were extremely high. When the D4H failed to match the traditional image of a hard-pushing cat, dissatisfaction turned into lasting dislike. Number 2. International Harvester TD15C. The International Harvester TD15C occupies a unique place on the list of most hated bulldozers from the 1980s because much of the resentment surrounding it had less to do with engineering and more to do with circumstance. The TD15 line had a strong reputation in earlier decades, and on a technical level the TD15C was intended to be a logical continuation of that legacy. However, the TD15C entered service during the final years of International Harvester's existence as a construction equipment manufacturer. By the early 1980s, the company was experiencing severe financial and organizational instability. Manufacturing consistency suffered, dealer networks weakened, and long-term parts support became uncertain. For owners, this translated into frustration that had nothing to do with operator skill or maintenance discipline. Operators and mechanics frequently reported cooling challenges under sustained heavy loads, particularly in hot climates or continuous land clearing operations. While not every machine experienced overheating, enough did that the issue became part of the model's reputation. Cooling inefficiency in a bulldozer is not a minor inconvenience. It directly limits productivity and increases downtime. Another issue was drivetrain durability under harsh conditions. Some TD15Cs performed reliably for years, while others suffered from premature wear, suggesting inconsistent build quality during a turbulent production period. Even when problems were repairable, parts availability could be unpredictable. A machine sitting idle due to a missing component quickly becomes a hated machine, regardless of its theoretical capability. The timing of the company's collapse compounded everything. When International Harvester exited the construction equipment business, many TD15C owners were left with machines that worked but were difficult to support. That sense of abandonment shaped long-term opinions more than any single mechanical flaw. The TD15C was not universally bad, but it became a symbol of lost confidence. In the 1980s, reliability was inseparable from support, and in that regard, the TD15C suffered greatly. Number 3. Allis-Chalmers HD11. The Allis-Chalmers HD11 entered the 1980s, carrying the weight of a respected brand name. Earlier Allis-Chalmers bulldozers were known for solid construction and dependable performance. Unfortunately, by the time the HD11 was in widespread use, the company itself was in decline, and that reality shaped how the machine was perceived. One of the most common complaints from operators involved hydraulic system reliability. Reports of leaks, inconsistent response, and higher-than-expected maintenance needs were frequent enough to damage confidence. While not every HD11 suffered these issues, the pattern contrasted sharply with the simpler, more forgiving hydraulics of earlier Allis machines. Undercarriage wear was another area of criticism. Operators expected durability comparable to previous Allis-Chalmers dozers, but many found wear rates higher than anticipated, especially in abrasive soils. Whether due to design changes or cost pressures, the HD11 did not live up to the brand's earlier reputation for longevity. Dealer and parts support further worsened perceptions. As Allis-Chalmers exited the construction equipment market, owners found themselves struggling to obtain components and technical guidance. Machines that might have been manageable with strong dealer backing became liabilities without it. The HD11's reputation suffered not because it was unusable, but because it represented a noticeable step down during a period when competitors were improving. In the 1980s, operators compared machines directly, and the HD11 often came up short in reliability discussions. In hindsight, the HD11 became hated largely because it arrived at the wrong time. It was a capable dozer burdened by a collapsing corporate ecosystem. Number 4. Case 1150B. The Case 1150B is one of the most polarizing bulldozers of the 1980s. From a structural standpoint, it was a tough, capable machine. From an operator's perspective, however, it frequently drew criticism that shaped its reputation for decades. One of the most consistent complaints involved operator ergonomics. Compared to competitors, visibility was limited, control layout felt awkward, and long shifts were physically demanding. In an era when productivity increasingly depended on operator comfort, this mattered more than many manufacturers realized. Transmission behavior was another point of frustration. Operators often described gear changes as abrupt, which increased fatigue and contributed to the perception that the machine was difficult to operate smoothly. While the drivetrain itself was durable, the feel of the machine made it less forgiving for inexperienced operators. Maintenance access also generated mixed reviews. While the 1150B was mechanically straightforward, some service tasks were less convenient than competing designs. For contractors managing multiple brands, these small inconveniences added up. Despite these criticisms, many 1150Bs worked reliably for years. The problem was not failure, it was experience. Operators disliked machines that made their work harder, even if the machine technically performed its job. As a result, the 1150B earned a reputation as a dozer that contractors tolerated rather than appreciated. In the 1980s, that was enough to earn lasting dislike. Number 5. John Deere 750. Early 1980s models. The early 1980s John Deere 750 illustrates how a capable design can still earn criticism when it arrives before its development curve fully matures. Deere was expanding aggressively into the crawler dozer market during this period, competing head-to-head with long-established players whose products operators already trusted. Expectations were high, and early missteps were remembered. Operators and mechanics commonly reported early service issues that, while not universal, appeared often enough to affect confidence. Hydraulic seepage and hose routing problems were frequent complaints on some early machines, particularly under sustained high temperatures. These issues were not catastrophic, but they contrasted with the reputation of Deere's agricultural equipment, which many customers expected to translate seamlessly into construction durability. Undercarriage wear patterns also drew criticism in abrasive soils. Some owners experienced wear rates that felt higher than anticipated for the class, prompting comparisons with competitors that seemed to tolerate the same conditions longer. Deere addressed many of these concerns over time with component updates and refinements, but first impressions stuck, especially among contractors operating tight schedules. Another factor was dealer familiarity. In regions where Deere dealers were primarily agricultural, construction-specific expertise lagged. Diagnosis and parts logistics sometimes took longer than owners expected, creating downtime that shaped opinions more than the underlying engineering. It's important to note that later 750 variants improved significantly, and many machines went on to deliver long, productive service lives. However, in the early 1980s, the combination of teething issues, competitive pressure, and high expectations meant the 750 developed a reputation for being not quite there yet. In an era when loyalty was earned job by job, that hesitation translated into lasting criticism, even after many issues were resolved. Number 6. Fiat-Allis FD20. The Fiat-Allis FD20 became a lightning rod for criticism, largely because it was born during a corporate and engineering transition. The Fiat-Allis joint venture brought together different design philosophies, manufacturing practices, and support networks. While the intent was to blend strengths, the FD20 sometimes reflected the friction of that process. Operators often cited electrical and hydraulic sensitivity as sources of frustration. Compared with older, more mechanically straightforward machines, the FD20 demanded cleaner maintenance practices and more careful troubleshooting requirements that weren't always communicated clearly to customers at the time. Inconsistent electrical connectors and early harness issues, while addressable, created the perception of fragility. Parts support compounded the issue. Depending on region, owners encountered confusion over part numbers and sourcing, particularly as branding and distribution evolved. Even minor delays can sour opinions when a machine is needed daily, and the FD20 suffered from that reality in certain markets. From a performance standpoint, the FD20 was not weak. It could push and grade effectively, and many units worked reliably when maintained properly. The problem was predictability. Operators and fleet managers value machines that behave consistently across conditions and ownership cycles. The FD20's variability, often driven by support rather than core design, made it harder to trust. Over time, Fiat-Allis refined its products and stabilized support, but the FD20's early reputation lingered. In the 1980s, a machine didn't need to fail catastrophically to be disliked. It only needed to complicate work. The FD20 became emblematic of that frustration during a period when clarity and consistency mattered most. Number 7. Komatsu D65A. Early 1980s. The early 1980s Komatsu D65A is a case study in how market entry timing shapes perception. Komatsu was still earning trust in North America and other Western markets, and early D65A machines were scrutinized intensely by operators accustomed to domestic brands. Common criticisms centered on cooling margins and undercarriage life under certain applications. In heavy sustained pushing, particularly in hot climates, some operators felt the machine required closer attention to cooling and maintenance than expected. These concerns were not universal, but they surfaced frequently enough to influence word of mouth. Control layout and operating feel also differed from what many operators were used to. While not inherently inferior, unfamiliarity can breed dissatisfaction, especially when crews rotate between machines. Early adopters sometimes felt they were learning the machine rather than simply running it, which affected productivity perceptions. Komatsu responded with refinements and improved dealer support, and later D65A variants earned strong reputations for reliability and efficiency. However, early impressions formed during the first half of the decade lingered. In competitive fleets, contractors often remembered the learning curve and early complaints longer than subsequent improvements. The D65A's placement on a most hated list reflects initial resistance and early challenges, not a fundamental design failure. It ultimately became a respected platform, but the early 1980s were a proving ground, and not all operators were willing to wait. Number 8. Caterpillar D3B. The Caterpillar D3B is perhaps the most misunderstood machine on this list. Its criticism in the 1980s often stemmed from application mismatch rather than inherent defects. Yet reputations rarely account for nuance. Designed as a smaller dozer for lighter construction, utility work and finish tasks, the D3B performed well within its intended envelope. Problems arose when contractors expected it to replace larger machines in heavy pushing or continuous high-load applications. Under those conditions, operators reported overheating, drivetrain stress, and accelerated wear outcomes that reflected misuse more than poor design. In practice, job site realities often forced the D3B into roles it wasn't meant to fill. When it struggled, blame landed on the machine rather than the application decision. Over time, these experiences accumulated into a reputation that was difficult to shake. Maintenance expectations also played a role. Smaller machines often receive less attention, and when service intervals slipped, performance suffered. The D3B's compact systems were less forgiving of neglect than larger, overbuilt machines, reinforcing negative perceptions. It's crucial to emphasize that many D3Bs delivered long, reliable service when used appropriately. However, in the 1980s, contractors valued versatility above specialization. Machines that demanded strict role discipline were often labeled problematic, even when they were functioning as designed. The D3B's place among the most hated reflects how misuse and expectation gaps can define a machine's legacy as strongly as engineering choices. Number 9. Drott bulldozers, late 1970s. Drott bulldozers from the late 1970s and into the 1980s earned a reputation for being difficult to own, not because they were fundamentally weak machines, but because they became corporate orphans at exactly the wrong time. Drott had a long history of producing crawler equipment, particularly loaders and specialized machines, but by the 1980s the company's presence in the bulldozer market was fading. From a mechanical standpoint, many Drott dozers were competent. Their frames were solid, engines were generally proven industrial diesels, and in suitable conditions they could perform routine earth-moving tasks adequately. The problem was never about headline capability, it was about ownership reality. As Drott's construction equipment business declined and ownership structures changed, dealer networks thinned rapidly. Parts availability became inconsistent, documentation became harder to find, and technical support was limited or non-existent in many regions. For contractors, this transformed ordinary maintenance issues into major operational disruptions. Operators often reported that when a Drott dozer went down, it stayed down. Even minor failures could immobilize the machine while owners searched for compatible parts or fabricated solutions. In an era when uptime was becoming increasingly critical to profitability, this was unacceptable. Another contributing factor was resale value. As Drott exited the mainstream market, residual values collapsed. Owners found themselves holding machines that were difficult to sell or trade, reinforcing resentment toward the brand. Even machines that ran reliably were viewed as liabilities rather than assets. It's important to emphasize that Drott dozers were not universally defective. Many worked long hours when properly maintained. However, bulldozers do not exist in isolation. They depend on supply chains, service knowledge, and long-term support. When those disappear, even good machines become hated machines. By the mid to late 1980s, Drott bulldozers symbolized a harsh lesson for contractors. A machine without support is a risk, no matter how well it performs on its best day. Number 10. Late-era Hanomag bulldozers. Late-era Hanomag bulldozers represent one of the clearest examples of how good engineering can still fail commercially. Hanomag had a long tradition of building robust industrial and agricultural machinery, and its bulldozers reflected that heritage. Structurally, many Hanomag dozers were well built, mechanically sound, and capable of long service lives. However, by the 1980s, Hanomag's position in the global construction equipment market had weakened significantly. International competition intensified, and Hanomag lacked the dealer density and logistics infrastructure necessary to support machines outside select regions. This reality shaped how operators experienced ownership. One of the most frequent complaints involved parts sourcing delays. Components that would have been routine replacements on other brands often required extended lead times for Hanomag machines, particularly outside Europe. For contractors running tight schedules, this alone was enough to sour opinions. Another issue was standardization. While Hanomag engineering was solid, some components were unique or less interchangeable than competitors' parts. This reduced flexibility for field repairs and made improvisation difficult. An important consideration in the 1980s, when job site repairs were common, operator familiarity also played a role. Control layouts, service procedures, and operating characteristics differed from dominant brands. While not inherently problematic, these differences increased training demands and reduced acceptance among crews accustomed to Caterpillar, Case, or Komatsu machines. As support networks shrank, Hanomag bulldozers increasingly found themselves sidelined. Not because they failed mechanically, but because owners lacked confidence in long-term ownership. Even well-maintained machines became hard to justify economically. The resulting resentment was not directed at engineering quality, but at uncertainty. In the 1980s, contractors needed predictability above all else. Late-era Hanomag dozers, despite their strengths, could not offer that assurance in many markets. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.